In general, we have to get to the point where we have no fractions. And kind of a general guideline. It will not always be the case, but a lot of times in order to do kind of some of the mathematics or the simplifying part of these problems, we want to rewrite things in terms of sines and cosines. Not always, but a lot of times we will. Okay, so we're going to want to rewrite. If you're seeing a cotangent, it's more likely that you're going to want to rewrite that as cosine of x over sine of x as opposed to 1 over tangent of x. Not always. There's going to kind of be some other problems where you're going to kind of see that that won't be the case. But in general, we have to simplify to the point where we don't have fractions anymore, and we want to rewrite in terms of sines and cosines. It tends to be the case that things will simplify a little bit nicer or clearer or cleaner. Okay? Yeah. All right, keep that reference sheet handy. There'll be some other things. The other thing that you're going to notice when we start working through these problems, there's kind of some patterns that develop. And you'll start to kind of notice that when you start working through these problems. There is no set like steps that I can give you to work through these. Every one of these is a little bit different. The other thing to realize is that in some instances, there are kind of multiple ways to kind of look at or figure out how to simplify these expressions. So Alicia might see this a little bit differently and solve it a little bit differently, simplify a little bit differently than Campbell or Braden. And that's okay, as long as you're getting to that final step. Okay? I'm going to try to color code to begin with, just to kind of help you guys see the parts. So we have, I'm going to try to remember to color code. Okay, so we have the cotangent of x over the cosecant of x. I want to rewrite that cotangent using sines and cosines. So cotangent of x using sines and cosines, what is that equal to, Grayson? How can we rewrite the cotangent of x?
Like one of the quotient identities?
Yep, it's one of the quotient identities.
Equals cosine x over sine x.
Cosine x over sine x. Beautiful. Yep. Okay. And then we've got to rewrite that cosecant of x. How can we write that? That's not a quotient, but that's a reciprocal. The cosecant of x, what is that equal to with reciprocals? Davis.
Wait, say that again?
What's cosecant equal to as a reciprocal?
1 over secant.
1 over, careful.
Sine.
1 over sine of x. Okay. So we've rewritten our cotangent, we've rewritten our cosecant. Now we have this complex fraction, right? We need to do keep it, change it, flip it. And when we do keep it, change it, flip it, this becomes sine x over 1. Guys, what happens with the signs? We're multiplying. Those divide out, don't they? We have 1 in the numerator, 1 in the denominator. So this ultimately is just, that's what's left. So this is just simplifies to the cosine of x. Okay? We're going to bounce around on this sheet. We're not going to go in exact order. We're going to look at number 3 next. I'm seeing a cosine, so I want to keep that the same. But I want to rewrite this cosecant of x.
1 over sine.
Yeah, and that's 1 over sine. Oops. So that is 1 over the sine of x. So we can combine this together, right? This is getting multiplied. When we put that all together, we end up with cosine of x over the sine of x. And what's that equal to?
Cotangent.
Yes,
Cotangent.
Braden, that is cotangent of x.
So we just have to like memorize this one?
Yeah, you have to memorize.
This is what I have been saying. The quicker you get these memorized, the easier this is going to be. But guys, you know your reciprocals already. You have known your reciprocals since like the second week of the trig unit that we did, right? So for most of this semester,
My brain can't.
we have talked about cream and sugar and reciprocals. Yes, cream and sugar. Okay.
Cream and sugar.
What now?
This makes no sense.
Why does it equal?
No, it makes sense. What do you mean? Cosine over sine.
Cosine of x over
Your
sine of
reference
x. Look at your reference sheet. That's a quotient identity.
There's something called reference sheet. Maybe you should check that out.
All right. Okay, I'm going to keep that cosine the same,
Little stank eye.
but I'm going to rewrite that secant. How can I rewrite that secant? Amira? Reciprocal of secant is? Shh. Cream and sugar. Reciprocal of secant is?
Come on.
Cosine. So this is 1 over cosine of x. There you go. Plus the sine we're going to keep the same. Chatham, that cosecant, how can we rewrite that? Think reciprocals. Yeah, so cosecant is equivalent to 1 over the sine of x. So guys, we have to look at each of these parts kind of separately, this term and this term. So we've got to do keep it, change it, flip it for each of those. Oops. So if we flip this up and flip that up, we're going to multiply cosine x over 1. Over here, we're going to multiply by sine x over 1. So we get cosine times cosine, which is cosine squared x, plus over here we get, oh man, I didn't review this. Who's got identities in here? Who's got identities in here?
Brandon doesn't have one. I don't have one.
Amira, what's your identity say?
Amira.
The sine squared of x plus cosine squared of x equals 1.
Okay, say that again.
Sine squared of x plus cosine squared of x equals 1.
Now try it without looking.
Sine squared of x plus cosine squared of x equals 1.
She's memorized.
Beautiful, she's got it memorized. That's Amira's identity. Chatham, what's your identity say?
1 plus tan squared x equals secant squared x.
There you go, you got it. And Chris's is just Chatham's with the co's in front. So keep going, Braden.
Equal to
Wait. 1 plus
1 plus cosine squared is equal to
cosecant squared x. There you go, good. Okay. So you guys, you're on your way. All right, cosine squared x plus sine squared x. What is that equal to? 1. That's Amira's identity. How pretty is that? That's beautiful. All right, we're going to jump down to 6, and then we'll look at 4. 4 is a little more involved. That's why we're waiting to do that one. It's a little more involved. Okay, we're going to jump down to 6. If we have sine of x over cosine of x, that's a quotient identity. What is that equal to?
tan x.
That's tan x. So if we have sine squared of x over cosine squared of x,
Tan squared x.
that would be tan squared x. You've got it. And then there's some special relationship between sine and cosecant. So what would that be equal to? Yeah, they're reciprocals, and we know reciprocals when we multiply them just to give us 1. And that looks like someone's identity. Tan squared x plus 1 equals,
Chatham's identity and
that's Chatham's identity, and it equals secant squared theta, or secant squared x. Boom.
Me? Because he was talking.
Because Braden's got this.
Where's the saying? Why would I talk over him?
I should have identity. That's fine.
Okay. All right, let's look at 4. This one is a little trickier.
Not trick, though.
Just identify as them all.
It's 1, yeah.
All right, this
No, no,
cotangent.
secant squared x. Secant squared x.
Whoops, I don't want to do that color. This cotangent. How can we rewrite that cotangent using sines and cosines? There you go. Good, Ryan. Cosine x over sine x. Okay, so now we have this. We have sine of x over 1 plus cosine squared x over sine x. So if you think about it, guys, we've got fractions that we're trying to add.
Multiply the other one by sin x.
We need common denominator, yeah. So we've got to multiply this fraction by sin x over sin x. And think about what that's going to give us. Avery.
Why are you using like cosine x over sin x when you do like 1 over?
Because remember, I was saying that a general guideline to help with simplifying, we typically want to rewrite in terms of sines and cosines. So we get sine squared when we multiply that. We already have this plus cosine squared x. And then we're over our common denominator of sine x. Guys, what's the numerator equal to? Amira, you had no idea that your identity was so special and important, did you?
But it's right here.
There it is. Sine squared x plus cosine squared x we know is equal to 1. So we have 1 over the sine of x. So what is that equal to? Cosecant of x.
Oh,
Because it's a reciprocal. Isn't this great stuff? I love it, love it, love it.
If you know it, it's great. But if you don't, it's like,
Like I said, the sooner you get these memorized, the
Yeah, you
easier
know it.
this will be. That's why in the meantime, you're going to have that reference sheet handy, right? Okay, I think we're going to look at 5, 7. We're going to hold off on 8 for now.
Up there during all of
wait.
it.
Okay, go back.
When you did your memorization, I took it down, but I put it back up.
Use your other
Oh,
hand.
Okay.
Got it? Good job, Suki. There you go.
Okay, so on this particular problem, on number 4, we needed to find a common denominator. Another kind of, I don't know, I'm not sure I want to call it a trick, but another method for some problems is that if you have multiple terms in the numerator and you have a common denominator, you may want to break it up. In other words, you may want to write each term separately over our denominator, right? So we can write this then as the cosecant of x over the sine of x minus the sine of x over the sine of x. So we still have to clean up a little bit there with the cosecant and the sine, but what's sine over sine equal to? So we get minus 1 here, right? But let's clean this up here. So cosecant, we know the reciprocal is sine, so this is 1 over the sine of x over sine of x over 1. We've got to do keep it, change it, flip it. And so we have 1 over sine squared x minus 1. But what's 1 over sine squared x equal to, guys? Say that again? Cosecant squared x. There you go. So cosecant squared x minus 1. Guys, that's an alternative form to an identity. That's Chris's / Braden's identity. Cotangent squared x, right?
I'll take all the other.
Okay. Braden's the fill-in for anybody who's
Yeah,
absent,
he really likes to do that.
because he's got them.
So is that just our answer?
That's it. Cotangent squared x is our final answer on that one.
What's a final covenant? Do we do 8?
I think we're going to look at 7, but we're not going to worry about 8 right now. So because I'm noticing that I've got cotangents in like all of the terms, we might be able to just stick with the cotangents. We could rewrite, but I'm thinking let's stick with the cotangents. And that would mean that we need to find common denominator. So when we find our common denominator and we multiply and we combine that together, that's what we get. Max, what does cotangent squared theta plus 1 equal to?
It's cosecant
Cosecant
theta.
squared. It's cosecant, right.
Cosecant what? Thank you. Cosecant squared theta. Those squareds are really important. So we get cosecant squared theta over cotangent of theta. I want to rewrite in terms of sines and cosines so we can simplify a little bit here. So this is a little more involved. They get involved here, guys. So the cosecant squared I want to rewrite as 1 over sine squared theta. And then the cotangent, I can rewrite that as cosine theta over sine theta. And now I need to do keep it, change it, flip it. All right, what happens here, guys? What happens with the signs?
One design on the bottom now.
Yeah, that one divides out and we're just left with this one here. So when that simplifies, we have this. Campbell and Max are going to be so lost. Ryan, you're not working with them. You're going to work by yourself. You can work with Grayson. Campbell and Max are going to have to struggle with this back here and figure this out. You got to get this going. All right. Remember, we can't have fractions. So what's 1 over sine equal to? 1 over sine of x is cosecant of x, good. And 1 over cosine of x is secant x. So cosecant of x times secant of x, boom, we're done. That's it. No, that does not equal 1. They are not reciprocals of each other. Good question. I'm glad you were thinking that. So, okay, we are going to hold off on number 8. The key on these is truly working, practicing, trying these. So that is what you guys are about to do.